Yeah, hello, good morning everyone. Yeah, this is Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering, Department of Electrical and Electronics Engineering, Hyderabad. So here, this is course about power system operation and control. So in this, today we are going to discuss about the topic called area control error. What is the concept of area control error? So how it will influence the parameters of the power system network, that we will see for today. So coming to the control area concept, all the generators are usually they are tightly coupled together to the coherent group. That means the whatever the couple of generators, they will respond to the changes in the load. That means it may be with the speed changer setting. So that control area is to be the frequency assumed to be constant. That means throughout in static and dynamic conditions, we are going to consider this concept, that is control area. So for the purposes of analysis, a control area can be reduced to a single speed governor system. That means which will be associated with the turbo generator and load systems. So according to that, we will consider. So here is a simple interconnected system. So this interconnected system is with electrical boundaries of the areas. So that is area 1, area 2, area 3 and area 4. So these areas are provided with particular boundaries 1, 2, 3 and 4. These are connected by one of the tie line. So this tie line is connecting from one of the areas to another areas at their respective boundary positions. So here we will treat the functionalities of the interconnected systems. So this may be taken place with the exchange or sale of the power to the distribution end to the various load centers. So that distributed areas taking other areas help, they may mutually share the power when there is a lag taken place on either sides. So that long distance sale and transfer of power that will be taken place in the intermediate connected systems. So coming to the concept of area control error, that is ACE, here it is to maintain the net interchange. So there we need to maintain the net interchange of the power within its area neighbors. So an AGC can use real power flow measurements of all the tie lines. So they will be emanating from the particular area and subtracts the scheduled interchange. That ready to calculate the error value and the net power interchange to be taken place together with the gain. So that should be from megawatt to the 0.1 hedge. So this is to be known as the frequency biasing condition. So due to which frequency biasing condition, it will be very easy to optimize the load frequency control as a multiplier on the frequency deviation. So this is also known as area control error. So this should be represented by one of the expression sigma k equals to 1 to pk minus ps plus b into f minus fd of the condition in megawatts range. So here P suffix k indicates the tie line power, which will be positive out of the areas, and here scheduled power is interchanged with the PS, and F naught will be the base frequency, which will be fact condition of the actual frequency. That means a fact is nothing but actual frequency. So positive S indicates that flow out of the area. So here ACE input to the AGC may considered with the real power summation of the ACE, which will loses the information as to the flow of the individual concerns. They may be under tie lines, but it is concerned with the area to the net generation of the power. So the tie lines transfers power through the area from one neighborhood to the another to the next end, which is known as wheeling power. So this power will be taken as the reversal conditions. That wheeling power cancels algebraically in the ACE conditions. That means one area purchases or sells the blocks of power in megawatt hours with the non-neighborhood of the utilities condition. So this is the area region. That means Here it should be considered with one of the AGC case. Here we will make the scheduled interfaces. This may be considered with the transmission network. So that may be associated with one of the measurement conditions. This entire area is covered with one of the regions of P1, P2, here with P3. That means the boundary area is suggested here under the given control. So these blocks of the control power systems are connected to the various regions with the transmission network positions as one of the conditions of the control areas 10 BFE. This will make the scheduled interchange of the system. So here one of the power system components as P1, P2 are connected to these areas means any mismatch or lagging of the power that should be in this region or boundary, that should be supposed to be sophisticatedly connected to another boundary when there is a lag expected from one system. So that may be done by one of the boundary of the area conditions. So it may be various components which will be connecting to the region from P1, P2, P3, P4. These are the boundaries which will be connecting to all the regions. So these regions are connecting means according to that conditions the regions are going to be operated sophisticated. So which will making the biasing opportunities to the power system network to these regions. So when there is a power cell from A to C, then areas are represented with the A, B, area C and D. Here the power coefficient becomes positive under area A condition. When it should be mutualing to the another area, this becomes AC is 0 with PG 0. And when it is area D, then AC becomes 0 with PS 0. When it is area C, PG becomes a negative sign. That means actual frequency will be considered with about 50 Hz range. So there will be mutual sharing or coupling in between the total regions or boundaries they are going to be considered in these regions. This will be exchanging the power from A to C. So here A will be treated as a selling power that should be from P to C. Then area control error for A equals to P is considered. Then power export starts until its AGC forces area control error to become 0. Then area C introduces P into its control error area constant. So power flows into area C until its area control error becomes 0. Then areas B and C are assumed to be must aware of the power exchange as they are going to be interconnected mutually. So the minimum requirements of AGC on controlling the interchange of the power and frequency have been established by NERC. That means this is introduced by North American Electric Reliability Council. So which is the compositions of the representatives of the major operating power pools. This committee specifies that the following criteria as a minimum performance that should be expected by AGC. So here normal system conditions are considered when AS equals to 0, that is at least once in 10 minutes period. The deviation of AS from 0 must be within allowable limits to the B. That means which will be under disturbances condition. So here area control error must return to the 0 within 10 minutes and corrective action from AGC must be within a minimum disturbance. Here daily load cycle is considered, which is about allowable limit, that is LD of the average deviation on power systems. That average condition over 10 minutes is considered as LD 0.025 delta L plus 5 megawatts range. This delta L is delta P by delta T, which is in megawatt per hour range. So the value of delta L is determined annually and it is taken from the daily load cycle. So a power system is said to be in a disturbance condition if the AS signal exceeds 3 LD value. So based on that parameters conditions, we will make the daily load cycle. So here daily load cycle will be started with the system load under megawatts and the time of the day case. So this will start with minimum daily load and it will be gradually increases and there may be drop here. This drop may be extending to the minimum daily load. So this extension to the peak daily load will happen. This region of the boundary is average daily load. This will be representing peaking load condition. And the fall which will be expecting from this region is represented with intermediate load condition. The tie end of the line with the minimum daily load condition will be known as base load condition. So these base load conditions are expected at various time regions. When it is the comparison with the megawatts of range with the time factors of the delay, if it is supposed to be considered from 12 p.m. and it will flows from 3 a.m. to 6 a.m., 9 a.m. like that, multiples of 3 ranges are considered till the 12 p.m. time is reaching. So 12 hours of delay will be considered. As it is the maximum rate of load change, then it may be represented with the delta T and delta P case. Right? So with that time delay of change, delta T, that change in power, the delay minimum daily load will be going to be obtained. So here it is considered with operation without central computers or AGC. That means power systems are capable of functioning even without central computer or AGC case. That means due to a result of turbine generator speed controls in the generating stations and natural load regulation conditions, the generators within that area are forced to share the load and causes the interconnected areas to connecting to the sharing load conditions. So this is one of the two area system with the area A and area B. They are supposed to be tie lining to each other by the interconnected AGC condition system. So here generation frequency characteristic curve is considered. So that should be let there be two independent areas named to be A and B. It should be without tie line flows as the circuit breaker is open. Then if there be a sudden changes in the load occurs in the area D, then area is considered as a single operating area representing to the remainder of the interconnection. So it is further assumed that the area shares the disturbance in proportion to their generating capacity and operating characteristics. So based on the operating characteristics, the area is considered to be a single operating area and they may be under interconnecting mode with the generation frequency characteristic curve. So here let the area generation frequency characteristic will be represented by the curve GG, that is generation in megawatts versus frequency in hertz, which is a composite response curve from all the generating units in area A. So that characteristic curve has a negative slope with the frequency. That means when the curve is considered frequency versus excess generation deficiency in generation, then the curve is to be taken as one of the slope, that is called as GG curve. So this curve is to be the one of the frequency characteristic curve, which is a composite response, curve from all the generation areas in the point of A. So here also it is considered with the base load. That means it should be considered with the frequency in hertz starting with 49.5, 50 and 50.5 maximal range. The load base value that should be tie-landed like this. That means from L to L it is going to be considered as one of the curve representation. So the area connected to the load is defined by the curve that should be shown here with the L to L. As there is should be increase in the load rotating condition, the machinery in the area is forced to increase the specific speed. So that basic equations are represented with the GA, that is G0 plus 10 beta 1 as the actual frequency minus nominal value, which will be taken as in megawatts. Then LA will be considered with L0 plus 10 beta 2 with actual frequency minus F0 in megawatts. So GA is the total generation and G0 is the base generation. Then LA becomes the total load, L0 is the base load. Then actual frequency, system frequency is considered to the limited extent, and the base frequency is F0 and beta 1 is cotangent of the generation. That means as the frequency characteristics is going to be considered in megawatt per 0.1 H, which will be treated as less than 0. That means beta 2 is considered as cotangent of the load frequency characteristics under megawatt per 0.1 H, which will be treated as one of the greater than value. So isolated operation in A response to load change is going to be shown here. This is considered with the amount of power that should be drawn with versus frequency in hertz, which is about 50, 49.9. So G2G generator consideration with L2L load is considered, as C2C is composite generator plus load conditions. As GA is considered with respect to LA, then that variations are represented as L2L dash, and G2C dash are one of the meeting points together at the particular junction as I0 case. So these conditions may be supposed to be varies with respect to the I1, I2 parameters, and they are exchanging together at the meeting junction of I0 and I1. According to that composition, the generator plus load considerations are must be treated as their respective manner. So for steady state frequency conditions, total generation is equals to total effective load. This condition must be treated. So this is to be defined by the intersection of G2G and L2L curves. Earlier we have shown with the I0. So that combined characteristics of the GG and LL is CC. That composite generation of the load frequency characteristic is given by GA equals G0 plus 10 beta 1. This is the actual frequency term minus F0, that is LA equals to L0 plus 10 beta 2, with the actual frequency minus F0 gives GA minus LA with G0 plus 10 beta 1 with the actual frequency minus F0 minus L0 minus 10 beta 2 with FA CT minus F. So increase in load in A moves to the load frequency curve to the position called LL. So the new system frequency will now be defined by the intersection of the labels. That means the labels are represented with I1 at a frequency of 49.9 Hz. Then it is desired to return to the system frequency, which is about 250 Hz, that is at the point of intersection I2. So setting the values of AGC in a shifting of GG to GG takes place to meet the frequency demand. That is about 250 Hz, as the consideration of the point is I2. So the resulting combined characteristics is C2C in terms of the increments. That means delta A is GA minus G0 plus L0 minus LA, as a 10 beta 1 as the actual frequency minus F0 minus 10 beta 2 of actual frequency minus F0, which is treated as a 10 BA into A delta F megawatts. So delta A is the difference of GA minus G0 plus L0 minus LA, which is the coefficient equivalent to the term of 10 beta 1 of actual frequency minus F0. This should be subtracted with the 10 beta 2 of actual frequency minus F0. The region boundary is considered here 10 BA into A into delta F, which is treated in megawatts. So here the basic functionality of the BA region, as it should be considered as natural regression characteristic, which will be treated as percentile generation for 0.1 H into A, that is called as generating capacity of A in megawatts. So that frequency deviation is considered as delta F, that is delta A by 10 BA into A, which is considered in Hz, that considering tie line flow with the frequency deviation is considered. That delta F must be delta A plus delta TL by 10 BA into A, which is considered in Hz. That summational coefficient delta A plus delta TL will use the net megawatt change. That will be the total power under various constraints. That delta TL will be the difference of delta GA minus delta LA. This total difference of the power from the region of boundary GA to LA is considered. That will be representing total load change. Here in this case, effect of tie line flow is considered as the interconnected operation. This should be considered with area 1 named as area A and area 2 as area B. So here the two areas A and B are interconnected through a line called tie line. This is called the representation of the tie line. So likewise, both the generation and load frequency are equals to 50 Hz frequency range. That means there is no initial tie line in the power. So based on certain conditions, when the power in megawatts versus frequency in hertz is considered, the range of frequency which will starts from 49.9, 50, 51.1 So during this instant, when it is compared with the opposite case of this power in megawatts, there will be the increasing the biasing condition with change in L, that is delta L, with change in G, that is delta G, with change in TL, delta TL, change in delta TL dash and delta TL double dash. These are the boundaries representing from I1 to I0, I1 to I2, I1 to I3, and a similar extent it will be extended up to I1 to I4 case. So these regions of the boundaries that should be extending to G to G dash, and increasing bias will be going to be takes place. That should be ranging in megawatts case. This range in megawatts will represent the frequency biasing conditions of the operations. So here certain disturbance occurs at the B point that should be causing the frequency to drop at 49.9 Hz frequency range. So that area generation does not match with the effective load in A case. That difference between I1 and I2 will give the difference case of the generation and load. This net excess power in the area will represent flow outs from A towards B case. That contributory effects in area A are supposed to be decreases in the load. That should be power which will be changing as a delta L and increases in generation case as delta G. That line flow from A to B as a delta TL as a delta GA minus delta LA, which is represented in megawatts. So this is the range of line flow which is standing from A to B is going to be takes place. So if area A has one of the AGC, then tie line flows increases. That means delta TL and delta TL double dash representing the increased amounts of bias due to AGC. That frequency change due to disturbance delta B for a tie line power flow from A to B is going to be considered. That delta F is delta B minus delta TL by 10 BB into B, which is represented in Hz. The delta TL coefficient becomes 10 BA into A with the delta AB by 10 BA into A plus 10 BB into B. That boundaries are representing with the coefficient which are in megawatts range. That means the total or net power change in B as delta AB minus delta. So this is equivalent to 10 BB into B into delta AB by 10 BA by into A plus 10 BB into B case. That delta AB coefficient as representing 10 BA into A plus 10 BB into B as in the product of delta change in frequency case. That change may be represented as delta F by delta AB as 1 by 10 BA into A plus 10 BB into. So these boundaries are counter-attacked on the AGC aspect with one of the delta B, delta TL and one of the delta BB condition. So this may give rise to the change in frequency of the conditions under normal boundary operating conditions. So due to which there will be a lack in system parameters that may be compensated with one of the load frequency control systems. This may goes to change further to the limited extent. So this is about area control error. So further cases we are going to extend this analysis with more examples, and these are some of the references whichever I have taken, and this gives the better understanding of these concepts for further extensions. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.